Now we are doing transformation of kind fx f modulus x, right? These type. So what happens here? Let's say if we have a function, for example, let's take a very simple function. Fx is equal to 2x, fx is equal to x. Let's take just x plus, let's take this. Okay. See what happens. So let's say if I'm graphing it, then this is going to be like this, a straight line. X and y. Now what I'm doing, f modulus x. So this is giving what? Just modulus x plus 1. No. So if you see for the first function, let's say if you're putting the negative values, let's say you're putting -4, -2, 2, -4, -2, let's say, then what we are getting? -4 plus 1. The y value we are getting 3, -3. For -2, we are getting -2 plus 1, which is -1. And let's say if you are putting 5, positive number, then you're getting 5 plus 1, 6. So these are the points we are getting earlier. I mean, if I draw it, then I will see it -4, -3, somewhere here, -4, -3, -2, -1, somewhere here. This is -2, -1, and 5, 6 is somewhere here, 5, 6, something like this. We're getting. Now, when we have done the modulus of x, see, then we are putting the same values, then how the y changes? Because modulus gives the only positive value. So it is -4 modulus plus 1. And now my y value is 5. Right? Now you see carefully that y value is 5. And when I was getting the 5 y value here earlier, I mean, when I was putting 4, then I was getting 5. Let's say if I put 4, then I get 5. And length, I'm putting, let's say, -2. So now my value is 3. So so how the graph is changed? If you see it carefully, so -4, I'm getting 5 here. And when I'm putting -2, I'm getting 3 here. And so my graph is something like this, isn't it?
Yes, sir. So
Right.
where does it get reflected?
When I'm putting x0, then it is 1. So it is 1. So see, so like if you see when x is less than 0, for x less than 0, all those values which you are getting, and for x greater than 0, whatever values of y you are getting. So when x is less than 0, the same y values you are getting here also. Right? For example, when you were putting 1, let's see this. When you were putting 1, then originally you were getting 2 from the normal function. And when you're putting -1, then what are you getting? 2. Isn't it? When you're putting x is equal to 2, what you were getting? 3, right? Y is equal to x plus 1. And y is equal to modulus x plus 1.
Oh, wait, I was muted all this time.
All right. And when you are putting -2,
Yes, sir.
then what you're getting? Then you're getting the same value, isn't it?
Yes, sir. Yes,
See,
sir.
so for negative values, you're getting the same value as you were getting for the positive values.
So basically, all the stuff that is in y minus will just go up.
Yeah. So basically,
Right.
so for x less than 0, this line get rejected. And same line we get what we have to the right side of the origin, or for the positive of x. So for the negative of x, you get the same values of y. So graph remains same. So now let's draw a curve. So for example, I'm writing a function f(x), and I'm drawing a simple quadratic curve. Let's say this is my curve. Wait a minute. Let me just draw it like this. So now I want a function f modulus x. That's what I want. F modulus x. So see what happening. I'm just drawing it at this time. So right side will remain same. There is no change.
So left third.
So left side will become exactly same as the right side. So this become this thing will get rejected. We don't get it. Yeah. And exactly same curve, what we have to the right side. So we get like this type of curve here, like this, this.
Okay.
So this curve, so like if I'm making the entire curve, then my entire curve will be like this and like this. This is right. This is F modulus X.
So basically, along with this, or like all the stuff that's there in the y-axis, like on the left side, will get cut off, and on this and all the stuff on the right side will just get reflected, and the whole graph will be the right side and the left side.
Absolutely. The right side get reflected to the in the left side. So y-axis behave like a mirror for the right side only, not for the left side.
Understood.
Okay, great. All right. So that is the F modulus X, and that we have already done. Like, let me just quickly write one for this also, So we covered up like everything, I mean, so let's say we have this, then for modulus X we are making, then this point become positive, and that's my curve, So my curve is something like this and this and this, this. Here you have to remember a few more things actually. Like whenever asymptotes are there, then things become a little different actually. When asymptotes are there, For example, like say if I have a curve something like say I'm making a vertical asymptote and horizontal asymptote, and it's kind of this rational function, See, let's say this is my function fx, and for this I'm making f modulus x, in this case. So over here, my asymptotes are both positive. I mean, like this is like positive to the x-axis and this is positive to y-axis, both asymptotes are positive. So in this case, it is fine. But let's say my asymptote is not positive, it is negative, Let's say I make a different curve and I make this line negative. I'll make a line here. It's a negative. No. And curve is something like this. Look at this. Right? Now
So
see asymptote goes, yeah, asymptote. So yeah, you tell me what you're saying.
No. So continue.
Okay, so asymptote is a y is equal to -2, which is a horizontal asymptote. That will change to y is equal to 2.
Okay.
Right. So see, so this is my new asymptote. Right. And it's the and see, the positive part will remain same. This one part will remain same, and that negative part will change. How this will change? This is 0. This will 0. This is going to be like this. Look at this. Right?
Yeah.
Right, to the new asymptote. So my curve is like how? The new curve is like this way, going down. It is intersecting the asymptote. That's fine, but it is asymptote to the one side. When x tends to infinity, y tends to 2. This is 2. Before it was when x tends to infinity, y tends to -2. This time it is like this. So that's how this hard asymptote has changed. Now what happened to the other side, of the asymptote? So because this entire thing is negative, so it has to be positive. So simply this part is going to be like the same shape, kind of reflection. All right, kind of reflection. So let's say this is intersecting at -3. So this is now intersecting at 3. So this was 1 before x tends to -infinity, y tends to -2. This is now when x tends to -infinity, y tends to 2. That's how it is. And here it is x tends to, let's say this point is let's say 1.5, for example. So x tends to 1.5, y tends to -infinity. But now the things changed, and we have x tends to 1.5, y tends to infinity,
Okay, so everything gets okay. So the asymptote also gets reflected. The graph goes upward.
Correct.
So but it's still two graphs, right?
Yeah, of course. Only the same. The only look at this. Only this part is like the same. This part only, which I'm making in this case.
But so that line is crossing the asymptote.
Yeah, let it be. You know,
That would be right.
asymptote can be crossed actually. You know, only asymptote mean is what? When x tends to infinity, then y is supposed to approach to a particular number. You know, then it is a Horner asymptote. So that's happening, right? At some point, it is getting the value. What is the asymptote value? That is fine. We can get it when we have a modulus function. Right, we can get basically asymptote is something that is not approachable, but at some point we are getting to when we have modulus function, and because this is what happening here, you know. But on the other side, when we are putting the large values of x, then we are approaching to 2.
Understood.
Right.
That's
how. So that's how modulus changes. You know. So that was the whole modulus. You know. So okay. So we will do like some more questions on modulus later.